Yes, good day students. Today we shall be studying static electricity. Static electricity. Now, let's quickly take a look at what electricity itself is. Electricity is a form of energy. Electricity is the flow of electron. Current electricity is the flow of electron. All matter is made up of atoms, and an atom has a center called a nucleus. The nucleus contains positively charged particles called the proton. That is, the positively charged particles are called the proton, and uncharged particles called neutron. Now, what is static electricity? Static electricity occurs when there is a buildup of electric charge on the surface of a material. Buildup of what? Electric charge on the surface of a material. It is called static because the charges don't move. The charges don't move. So the electricity we use every day involves moving charge. That is the one we use at home to power our electronics, and that flow through the wires, through the cables. They are called the current electricity. They flow, they move. But when we talk about static electricity, they are electricity that are made up of charges that does not move or flow. Now, where do the charges come from? If electron is equal to the proton, like we have talked about when we're dealing with atom, if electrons is equal to the proton, that means it is neutral. If the electron is greater than the proton, then it is negatively charged. If electron is lesser than the proton, it is positively charged, that is losing electron. Now, where do the charges come from? Rubbing material does not create electric charges. Please, I need you to note that rubbing material together does not create electric charges. It just transfer electron from one material to the other. So when you rub material together thinking you are creating charges, no, you are just transferring electrons from one material to the other. Either positively charged electron or negatively charged negative electron are being transferred. Now let's now look at behavior of electric charges. If you have a glass tumbler and a paper, you bring them near each other, there won't be any attraction. Ordinary glass tumbler and a paper, when you bring them near each other, no attraction take place, no even effect take place. But if you rub a silk cloth with a glass tumbler, what happens? Some electron is being transferred, will be transformed far from glass tumbler to the silk cloth, and that makes the glass tumbler to be positively charged and the silk to be negatively charged when you rub them together. So electron is being transferred. Now the glass tumbler that is now positively charged, if you bring it near a piece of paper again, there will be attraction. There will be what? Attraction, because the glass tumbler is now positively charged. There will be attraction with the paper. Now, having an ebonite rod, rub with 4, that is the 4 of your clothes. If you rub it together, some electron transfer from ebonite rod to the 4, and that makes the ebonite rod to be positively charged and your 4 cloth to be negatively charged. In conclusion, under that session, please, I need you to note that like charges always repel each other. In other words, if you have a positively charged material, 2 of them brought together, they will repel each other. So like charges repel. If you have two negative charge bring together, they repel. But unlike charges, that is positive and negative, they always attract each other. Now, let's quickly take a look at what conductor and insulators are. Conductors are substances that allow electric charges to flow. They are substances that allow electric charges to flow. Examples of conductor are, we have metals. metals. The insulator are substances that do not allow electric charge to flow through them. They do not allow electric charge to flow through them. So example are glass, ebonite, plastic, silk, wool. They are all insulator or non-conductor, and that is why they are able to retain charges on them. Now, these are the methods in which of charging method of charging. We have charging methods in which charges can be transferred, or charges can be moved from one material to the other. Number one, we have charging by friction. 2, we have charging by conduction. And 3, we have charging by induction. Now, let's quickly take a look at the charging by friction. Now, if you have object 1, you bring object 1, you rub it with object 2. Rubbing them together, electron get transferred from one object to the other. That is, like the first object 1, if it is positively charged, it loses electron. Object 2, if it is negatively charged, it gains electron. Now, let's now take a look at by charging by conduction. If you look at a body A that is charged with 2Q, charged with 2Q, that's body A. If you make it to have contact with this body B, which is uncharged, what happens? You discover that bringing them together, one of the charges will be transferred from A to B. Now, both having equal charges. Don't forget, here we have 2Q, and here we have no charge at all. So by the time you bring these two A and B together, they have what? Equal charges, Q and Q. Now let's move on to observation. Object A, when it touches object B, the total number of the charged objects get equally distributed between the two objects. That is, if you bring them together, they touch each other. That's through conduction. Charges will be distributed between the two objects. That is, equally distributed. Now, by induction, we can see here a positively charged rod. Here is a positively charged rod, a positively charged rod. But on this ball, on this metal ball, we have both negative and positively charged. So by the time you bring the positively charged rod near the ball, what we experience is that charges will flow. It will repel the positively charge on the bulb to the other side, which will flow through the ground, through this earth, and thereby leaving what we have here, leaving a negatively charged only, instead of the previously positive and negative charge. So here we have a positively charged bulb. So removing the earth, now we have successfully have what? A negatively charged bulb. That's charging by induction. You don't have to rub them together. In other words, you don't have to rub these two together. That is the rod and the bulb. You don't have to rub them together. Just bring them near each other. So they will be charging by induction. Now, let's quickly look at spot some differences between conduction and induction. In conduction, contact takes place. That is, the two bodies has to be in contact. Meanwhile, in induction, contact do not take place. In conduction, electron flow, but in induction, no electron flow. Then in conduction, same charge nature, and in induction we have no same charge nature. As you can see, we have the opposite charge. Then in conduction we have a charge remain permanent. Meanwhile in induction, charges is temporary. Now let's take a look at what is electroscope, which is a major instrument used in static electricity. What is electroscope? We have an electroscope is an instrument used to detect the presence of charge and the nature of the charge on an object. Not only to detect charge, it is also used to detect the nature of the charge, either it is positive or negative. It is very sensitive and delicate instruments. Electroscopes are of two types. We have the pith ball electroscope. We also have the gold leaf electroscope. Please take note of that. But the most popular one that is used mostly in our lab is the gold leaf electroscope. Gold leaf electroscope. Here is the structure of how it looks like in the lab when you see a real-time gold leaf electroscope. There's a picture of a gold leaf electroscope. Now, for drawing or assignment purpose, I will advise you to take note of this shape. It's simpler and it contains all what will be required of you in case you are asked to draw and label a gold leaf electroscope and state it or write its function. Here we have the metal disc, which is at the top. We have the rubber stopper, we have the metal rod, we have the gold leaf at this end, and we have the wooden base at this end. That's the wooden base. That's a picture of a gold leaf electroscope. Now please take note of these parts, because these are the parts that we actually look out for when you are marking a diagram. If it's properly and well labeled, then we have part of the electroscope: brass disc, we have the seal, we have the insulator plug, we have the glass jar, brass rod, gold leaf, metal foil strip, and the wooden base. Please consult your textbook for a simpler or comprehensive picture or diagram of a gold leaf electroscope. Now, what are the uses of static electricity? Dust removal is used in dust removal, that is pollution control, and it is used in photocopy, serigraphy, and car painting. So this will come to the end of our class today. We'll meet again next week for another class. Till then, stay blessed and stay safe. Bye bye.